In previous lessons, we came across quadratic equations that could not be factored. We tried all four methods that we've learned: common factoring, decomposition, sum and product, and difference of squares. And no matter which method we try to apply to it, it cannot be factored. So rather than saying that the equation is not factorable, there is a method that we can use and apply to equations that we deem to be unfactorable. Before we go through this process, we are going to do a little bit of a warm-up. We've got three different equations that we are going to attempt to solve. So let's start with this first one. We've got 5 equals 2x minus 7. Now, before we begin, what kind of equation is this? Is this linear, quadratic, or neither? So to figure that out, what we're going to look for is the highest value exponent on our variable. So we've got a variable of x. Okay, we don't see an exponent on it, but that means that there is an exponent value of 1 attached to the x. So that means that this is actually a linear equation. And if we have a linear equation, then we can solve it using our knowledge of collecting like terms and isolating for x. All right, so if we are going to collect like terms, that means that we're going to take this -7 and bring it over to the left-hand side. So that's going to leave us with 5 plus 7 equals 2x. 5 plus 7 is 12. And then to isolate for x, we're going to divide both sides by 2. So that gives us an answer of 6. If we move on to our next equation, is this linear, quadratic, or neither? Well, if I take a look at the exponent value on my variable, I have an exponent value of 2. So a value of 2 or a degree of 2 tells me that this is quadratic. So in order to solve a quadratic equation, remember that quadratic equations need to be set equal to 0. So that means we need to take this 4 and bring it over to the right-hand side in order to get all of the terms on the same side. And then we can collect like terms. So -12 minus 4 is -16. All right, and now that we have our quadratic set up, we just need to figure out what method of factoring are we going to use. So is there a common factor that we can pull out? No. Okay, at first glance, to me, this looks like a difference of squares question. Okay, I've got two terms separated by a subtraction sign. 16 happens to be a perfect square as well. So I'm going to go ahead and apply the difference of squares method. So that's going to give me x plus 4 and x minus 4. Remember that you need to take the square root of both x squared and 16. All right, now we still have to actually solve this equation. So we have to solve for the values of x. Remember that once you get your equation into factored form, you then are going to take your answers that are inside of the brackets and separate them. So I've got x plus 4 equals 0 and x minus 4 equals 0. And we're going to isolate for x in each case. So one of my answers is going to be -4. And my other possible answer is going to be +4. And our third equation here, we know that this is also going to be quadratic because if we check the degree of the highest exponent that we see, we have a degree of 2. So that tells us this is quadratic. Similar to what we did before, we need to bring all of our terms onto the same side in order to set our quadratic equation equal to 0. So that means we need to take this value of 2 and bring it over. So that's going to give us 0 equals x squared minus x plus 10 minus 2. And then if I collect like terms, I'll get x squared minus x plus 8. Okay, so now in order to factor this, this is a trinomial expression. So that tells us that we most likely can use either decomposition or the product and sum method, sum and product method, whatever you want to call it. Okay, however, can we apply the sum and product first? Can we use that shortcut? Remember that if your A value is 1, you can apply the shortcut. So because our A value is 1, we can use the sum and product method. So my C value is 8. So I need two numbers that are going to multiply to give me 8, but they have to add together to give me my B value of -1. So if I think of all of the combinations of numbers that can be multiplied to give me 8, the only combinations that work are 1 and 8 and 2 times 4. However, no matter how I work with these sets of multiples and use a variety of positive and negative operations, there is no combination that's going to multiply to give me 8, but also add to give me -1. So at this point, we would normally stop and say that this question or this equation is not factorable. However, today we are going to learn a way to figure out what the actual answers are or what the actual values are for x. So at this point, no longer can we say that something is not factorable because there is actually an equation that we can use to factor it. So questions that cannot be factored using conventional methods can be substituted into what we call the quadratic formula. And here's the quadratic formula that I'm going to box in red. Okay, it is x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 multiplied by a. Now remember, these letters a, b, and c, they are the coefficients or the numbers that come from your quadratic equation. Remember that a is the value that is attached to your x squared term, b is the value that is attached to your x term, and c is the value that stands alone. It is just a plain number found usually at the end of your quadratic equation. So once you have your equation and you decide that it can't be factored using any of the 4 factoring methods, we can then go ahead and use the quadratic formula. So when it comes to solving quadratic equations, there are 3 ways to solve a quadratic equation. We can use our regular solving method, meaning you're just collecting like terms and isolating for your variable, but that can only be used if there is only one x in the given equation. Otherwise, you are going to try to factor your equation using one of the 4 factoring methods that you've learned. And if you consider something to be not factorable, well, then we're going to proceed to use the quadratic formula. So in our practice example, we are asked to solve each quadratic equation by any method. So that means we could try to factor, and if we can't factor, well, then we will apply the quadratic formula. Our first equation is 2x squared minus 10 equals 8. So remember that we need to make sure that our equation is set equal to 0. So I'm going to start by bringing the 8 over to the left-hand side, which will turn it into -8. All right, our first step always is to check if we can simplify. Can we simplify this any further before we try to common factor? And the answer to that is yes. -10 minus 8 is -18. Okay, so let's try to factor this. Can we common factor, pull out a common factor in order to make it a little bit more simpler? And the answer to that is yes, there is a common factor of 2 between 2x squared and 18. So I'm going to pull out the 2. And then from each term, I'm going to divide out by 2. So hopefully you're at a stage now where you're comfortable with doing that division in your mind or in your head, and you don't necessarily have to show every single step on paper. If you still need to do that in order to help you get to the final answer, go right ahead. So 2x squared divided by 2 would be x squared, and -18 divided by 2 would be -9. All right, so the portion that is left over inside the bracket, no matter what type of question you're working on, you always want to check that what's inside the bracket, can it be factored further? A lot of the times the questions are not just pull out a common factor and then you're done. It can be factored again a second time and possibly even a third time. So the portion that's inside this bracket, x squared minus 9, this is actually a difference of squares. So it can be factored yet again using the difference of squares method. So knowing that, I still have my 2. I'm going to make 2 brackets. I'm going to set it equal to 0. So if I apply the difference of squares method, I'm going to square root x squared, which would give me x. Okay, we have one bracket that's going to take a negative sign, one bracket that's going to take a positive sign, and then the square root of 9 is 3. So this is the fully factored form of our equation. We were asked to solve, however, so now we're going to go ahead and actually solve for x. So remember that you're going to take each bracket separately and set it equal to 0. And you're going to isolate for x. So one of your answers will be positive 3, and your other answer will be negative 3. All right, in question B, the first thing I notice is that not all of my terms are on the same side of the equation. So in order to make this equal to 0, I'm going to bring the negative 2 over. Okay, there are no like terms that can be simplified or put together, so this is the equation that we are going to work with. So the first thing I notice is that I have 3 terms. Okay, so seeing 3 terms, you've got a squared term, you've got a term in the middle with an x, and then a plain number on the end. It's a trinomial. Usually is a good indication that you're either going to use decomposition or the sum and product method. Now, that being said, always check if you can pull out a common factor first. So between x squared, 3x, and 2, there are no common factors. So I can then proceed to see if I want to factor using decomposition or the sum and product method. Now, if I check my a value is 1. So because my a value is 1, I can just use the quick, faster way of using the sum and product method. All right, so my c value in this equation is 2, and my b value is negative 3. So I need 2 numbers that are going to multiply together to give me 2, and those same 2 numbers should add together to give me negative 3. So the number combination that is going to work is negative 2 and negative 1. Negative 2 times negative 1 is positive 2, and negative 2 plus negative 1, they add together to give me negative 3. So because we are using the shortcut sum and product method, simply all we need to do is set up 2 brackets. We're going to put an x in each bracket, and then our 2 magic numbers that we just came up with, we're going to transfer them into the brackets. So I can put negative 2 in one bracket and negative 1 in the second bracket. All right, and so that's our fully factored equation. We're now going to go ahead and solve for x. So I'm going to take each of my factors and set them equal to 0. So one of my answers will be 2. And my other answer will be 1. Okay, with question C, 2x squared plus 4x minus 11 equals 0. So we're ready to start because our equation is set equal to 0. We don't have to rearrange or move anything around. Are there any common factors that we can pull out? So between 2, 4, and 11, there are no common factors that can be used for those numbers. There are no variables in common between all 3 of these terms, so can't do any kind of common factoring. All right, we do have a trinomial, so we've got 3 terms, something with an x squared, something with an x in the middle, and then a plain number at the end. So that's a good indication that we have to use either decomposition or sum and product. Now, when I check my a value, however, my a value this time is a 2. It is not a 1. So because it's not a 1, I can't use the sum and product method, the shortcut. So that means that this question needs to be factored using decomposition. So I've identified my A, B, and C values. And our first step to decomposition is to take our A value and multiply it by our C value. So for us, that's going to be 2 multiplied by negative 11, which is going to give me negative 22. So I need two numbers that are going to multiply to give me negative 22. But those same two numbers have to add together to give us our B value, and our B value is 4. So go ahead, try to think of a combination that would work. So were you able to come up with a combination or figure out those two magic numbers? If you weren't able to come up with a combination, that's because there isn't one. So there are no numbers that are going to multiply to give us negative 22, but also add to give us a positive 4. So normally we would stop here and say that this question was not factorable. However, we are now able to figure out our answers because we've got our quadratic equation. So I've gone ahead and written the formula for the quadratic equation, or sometimes we call it the quadratic formula, on the screen. So in the place of A, B's, and C's that we see in the formula, we're going to use the numbers that we identified up here on the top of our page. All right, so if I input them, I'm going to have x equals, I have a negative sign, and then I'm going to put in my B value of 4. Got a plus and a minus sign. Then I've got a square root. Make sure you extend that square root out a little bit. Okay, we've got B squared, so that's going to be 4 squared minus 4 multiplied by our A value of 2 multiplied by our C value of negative 11. Okay, make sure you extend that square root. All of those numbers need to be underneath the square root. We've got our division bar. And then we've got 2 multiplied by our A value, which is 2. Okay, so now we're going to start to simplify this a little piece at a time. So we've got minus 4 plus or minus the square root. And then underneath the square root, we've got 4 squared, which is 16. Okay, and then the way that you want to read this is negative 4 multiplied by 2 multiplied by negative 11. Okay, so just be careful with the signs and how you use them and how you apply them. So negative 4 times 2 is negative 8. Negative 8 times negative 11 is a positive 88. You've got your division bar, and then in the denominator we've got 2 times 2, which is 4. All right, if I keep simplifying, I've got negative 4 plus or minus square root sign, and then underneath the square root sign we need to perform that addition. So we've got 16 plus 88, which is going to give me 104, all divided by 4. So we want to check and see if we can take the square root of 104, and if we get a nice even whole number. No decimals, okay? Obviously 104, however, is not a perfect square. All right, so the next thing that you are going to do is you are going to break this expression into 2. So I'm going to draw an arrow to show that I'm splitting it up. And the reason why I'm splitting it up has to do with this plus minus symbol. We are going to have 2 versions of this expression or this equation. Okay, we're going to have a version that is negative 4 plus the square root of 104 divided by 4. And we're going to have a version that is negative 4 minus the square root of 104 divided by 4. Remember that quadratic equations typically have 2 possible answers for x. So this is where you can see that this quadratic equation will have 2 possible answers for x. One answer will come from you adding, and one answer will come from you doing a subtraction. So using my calculator, if I were to input negative 4 plus the square root of 104, my calculator gives me roughly about 6.198. That's going to be divided by 4. 6.198 divided by 4 is about 1.5. So there's one possible answer for x. My other answer is going to be -4, take away the square root of 104. That roughly gives me -14.2, actually, let's round a little bit less. I'm going to keep it to 198. That's going to get divided by 4. So -14.198 divided by 4. So my other possible answer is going to be -3.5. So typically the questions will give you a decimal place to round to, so they may say round your answers to the nearest tenth. Remember that as you are doing your solution or working out your solution, try not to round too much. So notice that I kept 3 decimal places. That's a pretty decent amount. The more you start to cut off this number and round to, let's say, 1 decimal place or even 2 decimal places, your answer might be a little off at the end. So pay attention to the instructions in the question, and if the particular question doesn't give you any directions on how to round, then I will give you instructions on how to round off your final answer. Usually you want to keep your answer for x to 1 decimal place or to the nearest tenth. All right, for our last example, we've got something that looks nice and challenging. So we need to solve this quadratic equation for x. So we've got a lot of different things going on. We've got a lot of different terms. We've got some brackets involved. We've got an x squared term. Remember that in order to start factoring an equation, you need to have it in simplest form. So that means you need to distribute, potentially, you need to collect any like terms, and you need to make sure that your equation is set equal to 0. So in this situation, we definitely need to distribute. So we've got some distribution on the left-hand side. We've also got some distribution on the right-hand side. So if I distribute, that's going to give me 15x squared minus 12x plus 2x, which equals x squared minus 4x plus 12. And now it's just a matter of collecting like terms, but also bringing all of your terms over to one side of the equation. Now, whatever side you choose is up to you. You can bring all the terms over to the left or all the terms over to the right. It's whatever your preference is. So I've chosen to bring all of my terms over to the left-hand side. And now I'm ready to collect like terms. So 15x squared minus x squared is 14x squared. Negative 12x plus 2x is negative 10x. Negative 10x plus 4x is negative 6x. And then we've got a negative 12. So here is our quadratic equation ready to be factored. So our first step always is to check for any common factors. So between 14, 6, and 12, is there a common factor that we can pull out? So hopefully you recognize that there is a common factor of 2 that can be pulled out. Remember that the portion that's left over inside of the bracket, you need to keep checking if this can be factored any further. So we know that there are no common factors between 7, 3, and 6. So our next thing to check is, can we use decomposition or the sum and product method? Now this is a trinomial. We've got our squared term, we've got our x term, we've got our plane number term. Our a value is not 1, it's actually 7. So we have to try to see if we can factor using decomposition. So once you've identified your a, b, and c values, we can begin by multiplying our a times c. So that's going to be 7 multiplied by negative 6, which is negative 42. So we need 2 numbers that will multiply to give us negative 42. but also add together to give us our b value of negative 3. So let's think, are there any number combinations that could work for this situation? And again, hopefully you figured out that there are no number combinations that work to give us a multiplication of negative 42, but then an addition of negative 3. So we are going to have to use the quadratic formula or the quadratic equation in order to solve for x. So at this point, go ahead and pause the video. Try inputting your values of a, b, and c into the formula and see if you can come up with the answers for x. When you're ready, come back to see the full solution. So when you plug your values into the formula, just be careful with the signs. Your b value is a negative 3. So when you're inputting it into your formula, make sure that you use brackets around your negative 3. This negative is embedded into the formula. It doesn't just disappear. You need to make sure that you include it. So this is negative 3, or negative 1 times negative 3, plus or minus negative 3 squared minus 4 times 7 times negative 6, all divided by 2 times 7. If we begin to simplify, remember that if you have two negatives side by side next to each other or being multiplied by each other, two negatives make a positive. So this can be written as a positive 3 plus or minus negative 3 squared, which is 9. And then you've got negative 4 times 7 times negative 6, which is a positive 168, all being divided by 2 times 7, which is 14. Under the square root sign, we can add together 9 plus 168, which gives us 177. At this point, we are now ready to divide or break up our solution into two possible answers, one that's being added and one that's being subtracted. So when you go ahead and calculate your two possible answers for x, one answer should work out to be roughly 1.2, and your other answer should work out roughly to be negative 0.7.